For these two series circuit, we need to plot the voltage vector diagram. So because they are in series, it's convenient to keep current as reference, that is x-axis, because it is the same current flows through all the components. So let's take our reference as current. Now we know R we plot alongside the current, and XL is 90° ahead and XC will be down. Here there is no capacitor, so there is no XC, but here we will have XL and XC both. So in first case, we have two resistors in the series, R0 and R. So both of them will be along current. So this will be VR0, this will be VR. And voltage across inductor will be along XL, so that will be VL. So we do this phasor sum of all three and we'll get our voltage. And as expected, this is a inductor circuit, so voltage is ahead of current. These are just some formulas you must be aware of. So this is VL max, that is I max into XL. VR max, VR is anyway IR, and VR0 is also IR0. So this phase angle, he has not asked that how much voltage is ahead of current, but you can see that this angle phi will tell us how much voltage is ahead of current. Second case, we have a capacitor and inductor both in series, and it's given omega is less than omega naught, and then we have to plot it again. So you must, when he gives omega, frequency is less. So we know with less frequency, this capacitor will function quite good and inductor will not function at all. Because when frequency is less, the voltage is changing polarity very, very slowly. So across capacitor, charge will build up. But because this change is happening very slowly, the flux through this inductor because of current will not change a lot. So inductor will effectively behave like a straight wire. So that I am saying when the frequency is very, very less. And when frequency is very high, then we know the capacitor will behave like a short circuit. So capacitor will be ineffective. So here omega is less, that means capacitor is more effective than inductor. So whatever answer we get, we must know that our voltage should lag the current. So because we know in case of capacitor, current leads the voltage. So you can see that's what is happening here. So we'll take again current as x-axis. So R will be here, XL will be here, XC will be here. And now VR we can plot along x-axis for this. And the magnitudes of VL and VC, so again as discussed, with low frequency capacitor is more effective, so VC will be more than VL. So eventually the voltage will lie down. So if this is the angle phi, we will say that current leads the voltage by that angle phi. So what I explained about the frequency and the relation between omega and L, we can see here also. So it's given that omega is less than omega naught. So if we square both sides, omega square is less than 1 by LC, or omega L is less than 1 by omega C. So this is the impedance of the inductor, which you can see, not impedance, sorry, the reactance of the inductor is less than the reactance of capacitor. So because the reactance of capacitor is more, that is more effective. So if you multiply I on both sides, you can see that VC is greater than VL. And that's what we have done here. All right.